So next is tensile failure of the socket. So figure shows the weakest section at YY of the socket end. Okay, so you can see now where is the weakest section. So in the 3D diagram here you can see this is the weakest section. So stress calculation will be with respect to this weakest section. Okay, so what will be the stress equation then? Area. So what will be the area? So you can see for this area this diagram is used. Okay, so at section YY what is the area? Area is equal to area of the shaded portion will be equal to what will be the area? Pi by 4 d1 square, that is outer circle diameter minus inner circle diameter, minus d1 minus d2. So total d1 minus d2 into t, the area of this blank portion. So I am getting the area of the shaded portion. This will be the area. Okay, so what will be the tensile stress then? Tensile stress will be equal, sigma t is equal to p upon area. So p is equal to pi by 4 d1 square minus d2 square minus d1 minus d2 into t into sigma t. Okay, very simple. Always we have to consider the weakest portion or weakest section. So weakest section is the section where cross section area is the least. Okay, so next is shear failure of Cotter. So what the Cotter is? So you can see the diagram now how the shear failure will take place. So the Cotter joint is subjected to double shear stress. So you can see now. Okay, I can zoom this diagram. You can see this, the shear stress. So where is the shear stress acting? On the two sides of the Cotter. So this is the lower part of the Cotter, this is the upper part of the Cotter, and on this area, shear stress is acting. So shear stress is acting on two sides, on upper side of the Cotter and lower side of the Cotter. You can see here diagram. So which force or which area undergoes the shear? This cross section area will undergoes the shear. So we know that for shear stress, area is parallel to the direction of force. So this is the direction of force, either P2 by 2 or P. So upon the area parallel to this force, so which area is parallel to this? B into T is the shear area. What will be the equation then? Yes, you can imagine it will be force upon area. So what will be the force? Shear force sigma T is equal to tau. Okay, that is tau is equal to force. Which force is there? P upon area. So if I am considering P, so area will be double. That means area on upper side, area as well as area on the lower side. Or if I am considering only this P by 2, then there is only one area. Okay, so here equation will become tau is equal to P upon 2bt. Why it is 2bt here? Because it is area. So what is this? I am considering this one. So force upon area. So first area and second area. Two shear areas are there. So B into T into 2 is the shear area. Right. Next, shear failure of the spigot end. So whenever I am saying spigot is nothing but, you must remember the diagram of spigot, the shear failure of the spigot end. Okay, so whenever we are considering spigot, okay, so shear failure, the area of the two planes at the that resist shear failure is A into d2. Okay, so you need to understand here. You can see spigot end, this is the spigot end in which Cotter is inserted. Okay, so whenever we are applying force, so whatever portion which is in spigot, so you can see this portion is in spigot. Okay, A, so A into d2 is your shear force. A into d2 is your shear force. Okay, so here we are getting tau shear stress is equal to P upon twice of AD2. So why it is twice of AD2? Because this cross section area that will also be from back side, so that becomes P upon twice AD2. So P is equal to 2AD2 into tau, where tau is permissible shear stress for the spigot. Next, shear failure of the socket. Okay, the socket end is also subjected to the double shears as shown in figure. So you can see now socket end will also go for it can also generate for double shear stress. So you can see area under shear, this is the area under shear. So I have shown here area under the shear. How much is the cross section area here? Cross section area is the